Okay, in this example problem, we are looking at two Ethernet data rates, 100 megabits per second and 1 gigabit per second. And what it asks us to do is to calculate how long it takes to transfer a file of 2 megabytes at each of these data rates, and asks in part C, how much longer does it take at the slow data rate than at the fast data rate. Okay. And the first thing I'm going to do is I'm going to write down these data rates and call them R1. We've been using R sub B for bit rate. And so I'm going to go ahead and use RB, but I'm going to call it RB1 and RB2. Okay, and bit rate 1 is 100 megabits per second. And we can write this as 100 times 10 to the 6th bits per second. And R2 is 1 gigabit per second. And we can write this as 1 times 10 to the 9th bits per second. Notice that I can take the 100 e to the 6th and write it as 1 e to the 8th bits per second. And I can also write it as 0.1 times 10 to the 9th. Okay, here 10 to the 9th, those things are bigger than the 10 to the 8ths, and so if I get bigger on the exponent, I've got to get smaller by the same fraction on the number out front. Okay, so these two are equal, and you can see then that the 100 megabits per second is 1/10 the speed of the 1 gigabit per second. Here's 1 e to the 9th, here's 0.1 e to the 9th. So it's 1/10 the speed, and you should know that from just reading the initial problem, because when you get to 1,000 megabits per second, you're at 1 gigabit per second, and 100 is 1/10 of 1,000. Okay? So let's calculate, first of all, let's write down the size of these files. It's a 2 megabyte file, and we're using a capital NB for the number of bits in a file, and that is 2 megabytes, which is 2 times 10 to the 6th bytes, which is 2 times 10 to the 6th times 8 bits, or 1.6 times 10 to the 7th. You can say 16 times 10 to the 6th, or 1.6 times 10 to the 7th. And I'm going to go ahead and write 1.6 times 10 to the 7th bits. Okay? And now we're going to use the equation for datacom, which is analogous to distance is equal to velocity times time. Okay? This is the one where if we go 60 miles an hour for 2 hours, we're going to go a distance of 200 miles. 60 miles an hour for 2 hours, we go 120 miles. Okay, here we have the number of bits is equal to the bit rate times the time. And so this is bits, units of bits. Bit rate is bits per second, and time is seconds. Okay, and so we're going to use this equation and say that NB is equal to RB times the time. And we're going to apply that to both parts A and B when it says how long does it take. It's asking for the time. And we're going to call them T1 and T2. And if I solve this equation for T, I get T is equal to NB over RB. And I'm going to call this T1, and I'm going to use RB1 in that calculation. So I just plug in now 1.6 times 10 to the 7th bits divided by 1 times 10 to the 8th bits per second. And let's see, I don't need a calculator for this. It's 10 to the 7th divided by 10 to the 8th is 10 to the minus 1. And so yeah, 10 to the minus 1. And so 10 to the minus 1 times 1.6 is 0.16 seconds. Or 160 milliseconds. Okay. Similarly, T2 then is NB over RB2, and this is 1.6 times 10 to the 7th divided by 1e to the 9th. And this is e to the 7 divided by e to the 9. 10 to the 7th divided by 10 to the 9th is 10 to the minus 2. And so it's 0.016 seconds, or 16 milliseconds. One-tenth the amount of time. And you could just say, you know, in words, if you wrote out a sentence, you could say, okay, T1 was 160 milliseconds, but the data rate for 2 was 10 times that, so the amount of time will be 1/10, or 16 milliseconds. If you write that out in a sentence, it's fine. Here I'm showing you plugging into all the numbers and making sure that it all makes sense at the end. How much longer does it take for part C? Well, the change in time, the amount of time difference, is the 160 minus the 16, which is 144 milliseconds. Okay, so that's how much longer it takes to download it at 100 megabits per second compared to 1 gigabit per second. Okay, hope this makes sense and helps.